basic CRUD of data, which is create, retrieve, update, and destroy. So that's where we're going over the next 2 weeks. Several weeks for SQL, because we'll also learn how to design a database. And there are already questions about it, because there was an excellent question on Piazza the other day about how do you handle inheritance with a flat data model, or not a flat data model, but a data model like JSON or XML. And the answer is that they're kind of incompatible. What we've been looking at is an object model where you've got encapsulation, so you've got the collection of data, you've got relationships between that data, but you also have inheritance, where you can have one class inheriting from another, right? Like you did yesterday in your lab, where you take common functionality and common state and you promote it up to the superclass so that the subclasses can inherit that. Basically so that you don't have to repeat yourself. Not only do you not have to repeat yourself, but if you want to extend the behavior of your classes, then you've minimized the development that you need to do. If you've already got a class, if you want to create a new bank account, you've already got this generic bank account that you can extend from, and now you've got most of the behavior that you're going to want. That is incompatible with a data model like JSON and XML, which are it's just data. It's no behavior. They're not objects because they don't have functions to them. And because they don't have functions, they don't have a well-defined way of doing inheritance. There are mechanisms to take care of that, but that's what we'll look at when we look at databases. All right, so to rectify the difference between those two models. Just as a really quick review here, remember how inheritance works. When you instantiate a class, you're creating a virtual table. I drew it out last time, that this table is created for a savings account and this table is created for a checking account. They both have similar functions, but when you override a function, when that virtual table is created, a reference to the correct function that you actually want to call is created. So that when you actually have a generic bank account, you don't know if it's a savings account or a checking account, and you want to call one of its methods, what happens is called dynamic dispatch. That at runtime, because this virtual table was created, you want to call this function. Okay, I'll call this function. That function refers to that function over there, so that's the one we end up calling. And in a different virtual table, it refers to a different function. So it's all opaque. You don't have to worry about any of that stuff. It's all a runtime mechanism. It's not, the compiler doesn't handle it, because if you've got a generic bank account, at compile time, it could be anything. It could be a savings account. It could be a checking account. You can prevent this by making methods or classes final in Java. To prevent overriding, you're basically making a virtual. All functions are virtual by default in Java. To make them non-virtual, you slap on a final, and you can't override them anymore. Likewise, you can apply the final keyword to a class, which means that you can't override. You can't extend the class anymore. You'd want to do that if you've got some very well-defined classes that are stubs that you don't want extending their behavior. For example, strings or integers or things like that. Yes, ambassadors, come on up. All right, so before we continue, we do have a guest today to talk about the ambassadors for engineering, right? Mm-hmm. Just ambassadors?
Engineering ambassadors.
Okay. Okay, go ahead.
It's okay.
Otherwise, I don't know where it is. Sorry.
No, you're good. Hi everyone. My name is Sarah Mendez, and I'm actually a junior engineering ambassador with the College of Engineering. And right now we are in the recruitment process, so I'm here to talk to you guys a little bit about that. Has anybody ever heard of engineering ambassadors or know anybody in it? Yeah. No. Okay. Thank you.
Yeah.
Right. Can you hear me?
Yep.
Okay, good. All right. So I'm guessing only one, because I saw one hand back there. All right. So Engineering Ambassadors is basically a program where students from the College of Engineering go out and we basically give presentations and also work events for students K through 12, where we go out and we spread the word about engineering and what it actually is, to kind of push away the stigmas that students may have growing up with it and really show them what it's all about and how broad of a topic and style of life it is. So one of the presentations that I usually do is called What Floats Your Boat. And that's one of the examples as what we give the students. And we basically talk to them about what makes boats, how engineers are working on them, but also all kinds of engineers work on them. And our motto in Engineering Ambassadors is we work for the health, happiness, and well-being of society around us and to make it a better world for our newer generations. So do any of you guys like working with kids? First thing. Raise your hand high. Yeah, so a lot of you. Okay, so yeah, we work with the kids a lot. And if you really like it, it's a good thing to do because we really do like inspiring younger generations. Sorry, I'm a little out of breath. But, I'm so sorry.
That's all right.
I don't know why. That was really awkward. Okay, sorry about that. So basically, engineering ambassadors, like I said, we spread the word about engineering and we teach younger students about what it is and what they can get into and what they can get involved in. So engineering ambassadors, the process of how we do recruitment is we have an application online. So if you go to unl.edu and you look in the search bar for engineering ambassadors program, it will actually come up. And we have our applications open until, I believe, February 12th, near the end of that. And then we start the recruitment process where you'll go through and we are selecting 12 new ambassadors right now. And the nice thing about it is there's a lot of benefits. One, you can put it on your your references in when you go into a job, and that's actually something that will set you apart. Also, it can count as volunteer hours if you need to. And you also get a $250 stipend during the school year, and that helps with like gas and food or anything else, or you can use it with whatever you want. And on top of that, you get the experience of working with a lot of different people, and you get to meet a lot of connections outside of ambassadors. And as you go through the program, you start as a junior EA, like myself. And then once you're in the ambassador program for a year, you become a senior EA, and then you can become a peer mentor to the newer EAs throughout the upcoming years. So this upcoming year, I will actually be a mentor to probably one of you if you decide to join. But yeah, so if you go on and you click on our website, you can scroll down and we have all of our information. So we have a presentation topics slide, which is basically all the presentations that we give. And they range from anything in biomedical engineering to stuff in architectural engineering, mechanical engineering. So we have all of it. And then we also have Meet Our Ambassadors page. And that is where you can kind of look at all of us and you can see a little bit of background on us. And these are all of them, and we range from Lincoln to Omaha, so we're in both branches. And then we also have a lot of different programs around the country. So there's this big conference that a lot of us can go to, and you get to meet all the other EAs, you get to do workshops, and it's really a lot of fun. We also have mandatory meetings every Wednesday at 7 p.m., but when you first come in, you'll just be doing your training, and then the next year you're going to be required to have that meeting every Wednesday. But in that meeting, we cover topics of the week. We do presentation outlines for what we're going to be presenting at new topics, and then we also fill out our workshops for our junior EAs and make sure that they understand what they're doing, how to do the presentations, and like where to go and all the coordinations that we have. Okay, never mind, we moved it. Okay, so February 27th is actually our deadline, and all the information that you would need is right on this page. You can go ahead and just submit everything, and once it's in, we'll receive it, and then we start reviewing. And after the 27th, I believe we have a grace period of like a week where you can talk to our directors, Sally and Kate, and they will let you know if you can still create a meeting with us, or if you're interested but don't want to join yet, you can always talk to them and they'll put you on our wait list for the next year. So that's just a little bit. And some presentation topics that we have, like I said, are aquaponics, we have bridges, hydropower. If you want to click on the one for, roller coaster engineering. So roller coaster engineering is basically our most popular presentation that we do. So you'll probably learn that if you become an engineering ambassador. And it just tells students about how we build roller coasters, what they're made of, the physics behind it, and also the mathematics behind it. So we put in a lot of different components into our presentations. And then the level, as you can see, is any age. And each of our presentations is ranked by a level. So we have kindergarten, we have elementary, and then we have high school. And sometimes we will actually go into conferences and we'll present to colleges. I've personally presented to a crowd of like 200 is my max that I've done, but we've had people who've done like a full-on assembly for a college. So It's just really interesting, all the different experiences. And as you go through the process, you will actually get a chance to pair up with another new EA, and you get to create your own presentation. And you'll have kind of like a guideline of what we're looking for, but overall it's up to you and it's what you want to do, which is really cool, I think. So if you guys are interested in joining the Engineering Ambassadors, you're more than welcome to submit your application, and we are looking, like I said, for 12 new spots. So it is very competitive here in Lincoln, just because so far we've received, I believe, 20 to 30 applications, depending on what the day is. So yeah, if you guys really are interested, we would love to have you guys. And you don't have to be a BSc, you don't have to be in agriculture, you can be any engineering, because we welcome all kinds. So yeah, thank you.
Thank you. Sorry about that. No problem. And I went ahead and posted the link to that on to this website on Piazza just now. So I've been to a couple of their booths before, and they do have excellent work with students, and especially K through 12 kids. So it's a really good opportunity. I'd suggest that you take a look at it in case it's right for you. All right, so what we're going to do today, well, first of all, what we're going to show is some pitfalls to inheritance specifically that are kind of somewhat resolved in certain programming languages and not resolved in other programming languages. So just as a toy example here to show you this pitfall, and then we'll talk about it. Say that I've got an animal. Right? Say that I create an animal class, and it's got legs, it's got whatever, it eats, it speaks, whatever. And I've got our two of our favorite animals, dogs and cats. Right? Well, a dog is an animal, right? And a cat is an animal. So you could say that you inherit everything that an animal does. Up here, if you've got an animal, say, with a speak method, right? Well, what does a dog say? Well, bark, right? So it's got a bark method that when you call the speak method on an animal and it's a dog, then it barks, right? And a cat, what does a cat do? Meow, right? All right. The pitfall is what happens when you allow what's called multiple inheritance. So if I've got a class and it's derived from another class like this, right? A dog is an animal. That's pretty straightforward. But what happens when I try to inherit from multiple classes? So I've got this class down here that inherits from both a dog and a cat. Right? Well, what is it, first of all? What do I call this thing? Cat dog? Okay. All right. Now, all right, if you want to make this design, fine. But now, when I call the speak method, what does it do? Yeah, howls, right? Whatever, bark meow or meow bark, right? It's ambiguous, right? You don't know just by looking at the design here what the intention is. Now, this is a toy example, so obviously you would never want to do something like this because there's no such thing as a cat dog. But you might be tempted to do this in some of your other designs. This is called the diamond problem. Why is it the diamond problem? Because look at the shape that this class diagram has created. It's a diamond, right? And it's what happens when you inherit from multiple classes. You create this diamond shape or this lattice shape in general, right? And the problem is some ambiguity. When it speaks, what does it say? Does it inherit the meow or does it inherit the bark, right? And from the design, you can't tell. Some programming languages allow you to do this. For example, C++. In C++, you would resolve the diamond problem by specifically saying that, oh, my speak method, I inherit that from the cat, and therefore it meows. Or my speak method inherits from the dog, therefore I bark. Or my speak method does something entirely different. But you still have the problem of this doesn't look like a good design, right? You still have the problem that just by looking at the class diagram, you don't know that. You'd have to actually dive into the code and see what it actually does. So this is the diamond problem. And you try to avoid it. It's not in Java. Java doesn't have this problem because you have a single inheritance hierarchy. You cannot extend two classes. You can implement, as you might have seen yesterday, you can implement multiple interfaces if you want to, but then you're not inheriting anything because an interface is a purely abstract class. It doesn't have any methods for you to inherit. It has methods that you have to implement, right? And you can inherit that from another class if you want to, but you don't have, you don't have this ambiguity problem in Java. Right? All right, let's look at another problem, and I'm going to turn my paper this way. So, how do we categorize animals? Right? So, do you remember the 7 layers? Kingdom. What do I start at the top? Kingdom. Does anybody know the mnemonic device for this? Not a single person? Phylum. Then what? Class. Then what? Order. Then family. And I can take it from there, I think. Genus and species. Right? Is that right? All right. This is how it's done in biology. Think of a class diagram like this, where you've got a species and then it inherits from a genus and it inherits from class, it inherits whatever, whatever, whatever. Suppose that I want to define a new class or define an instance of a class. Oh, okay, it's order, right? Wait a second, what's inherited from it? Okay, well, I have to look up to class. Okay, well, no, I didn't find it there, so I have to look up to phylum. Oh, okay, it was way up here in kingdom was what I was looking for. Or maybe, okay, I've got order here. Maybe I want more specialization. Maybe I should look down in the hierarchy, right? And if you've got a deep hierarchy like this, what are you always doing? You're always looking up, then looking down, then looking up, then looking down. Kind of like watching a yo-yo, right? A yo-yo goes up and down, and if you watch the you don't watch the yo-yo, do you? You would go up and down, right? You don't want to do that with your class diagrams. You don't want a deep inheritance hierarchy. That's the yo-yo anti-pattern. An anti-pattern is something that is not a good practice, that is a kind of a bad habit, right? So you don't want to do the yo-yo problem. And again, the problem is, some of you remembered that it was kingdom, phylum, class. How did you remember that? A what? Oh, there you go. King Philip came over from. Okay, but at least you remembered that it was genus and species, right? That's called a mnemonic device. When we've got a complex hierarchy like this, we need those tricks to remember how to do it. And if you need tricks to remember how you designed your classes, that is a huge red flag that you're violating or that you have a yo-yo anti-pattern. Keep things shallow, keep things simple, right? And in general, prefer composition over inheritance, which we'll talk about later. But this is the yo-yo anti-pattern, okay? Avoid deep hierarchies. Another problem that I'm going to switch over to code mode here and walk you through here. So desk and desk. Come on, desk. There we go. All right. I'm going to switch over to Eclipse here, and we're going to design a few things here. So I've got 3 classes that I've already created here: a rectangle, a square, and a shape. Propose a relationship between those 3. So what should be at the very top, first of all? Shape. Because a rectangle and a square, they are shapes, right? What's the relationship between a rectangle and a square? A square is a rectangle. So let me go ahead and enforce that through an inheritance hierarchy. Extend shape. There we go. Because a rectangle is a shape, and a square is a extends. Come on, rectangle. There we go. There. Now I've got this. It's not a deep hierarchy. I've got shape, rectangle, and square. Okay. Shape, I'll leave that alone for now. But let's go ahead and go up to rectangle here. Tell me what defines a rectangle. 2 sides. So private, let's say double side 1, or private double side 2. Should I call them side 1 and side 2? What should I call them? Length and width. Okay. I was going to go with height, but we'll go ahead and go with width. All right, that's fine. Let me go ahead and go up to, so again, you can't see it because it's on the other side here, but I'm going to go ahead and generate my getters and setters. Right? I'm going to generate all of them. Generate, there we go. Great. Now over here in square, what is a square? How do you define a square? It's a rectangle with equal sides, right? So, but I've already extended rectangles, so what's inherited here? All of it. So it's got a length and a width. Okay? Let me go ahead and play around with this now. By creating a new class, I'll just call it demo with a main. There we go. All right. Let me go ahead and create a square. S is equal to new square. All right. And let me go ahead and set its sides. S dot set length to, I don't know, it's a 10 by 10 square. Is that a 10 by 10 square right now? Let me go ahead and go back to square here. In fact, let me go over to shape. And let me go ahead and generate a toString method because I don't want to think generate this. No, darn it. I don't want shape generating that. I want rectangle. So source generate toString method so that I don't have to. There we go. And it put it not where I wanted it, but it put the length. And then, in fact, let me go ahead and get rid of that. The length and the width there. Okay, so let me go back to my demo here and print out my square. System.out.println s. Right. Let's see what it should. It should be a 10 by 10, right? Yeah. Don't worry about that. It's a 10 by 0. All right. Well, I can fix that. I can go ahead and set length to. I've got the length to 10, and I've got the height, or what we said width. Sorry. 10. All right, now it's a 10 by 10. Yeah. All right. But it's a square, right? S is a square. What's to prevent me from doing this? Let me go ahead and run it again. It is a 10 by 20. Is that a square? No, that's a rectangle, right? And it's an artifact of the fact that I've inherited from another class, but in the subclass, I've allowed mutators, that is setters, to change the state of my object so that it no longer conforms to the definition of my object. Right? This is an inappropriate inheritance hierarchy because down here I can change it so that a square, the object is still a square, but its properties make it no longer a square. Right? Sometimes you do this with a circle and an ellipse instead. A circle is an ellipse, and an ellipse is a shape. Or a curve or whatever, but you can make it so that a circle becomes oblong and becomes an ellipse instead. I think the square, rectangle, and shape are easier to understand at least here, geometrically at least. So we've got a problem here. This is not an appropriate inheritance design because we can change a subclass so that it's no longer that subclass. In fact, to show you that it is indeed is still a square, I'll go ahead and say s.getClass. There we go. Let me go ahead and print that out. What is it? It's a square, right? It's not a rectangle. It is a rectangle, and I can check for that. If s is instance of rectangle, print system.out.println S is a rectangle, right? And I can do something similarly for circle. I hesitate to show you this, not circle, square. There we go, and square. I hesitate to show you the instance of keyword because probably you shouldn't be using it. There are probably better ways to do it. If you find yourself using the instance of keyword to determine is this product a piece of equipment or is this product a consultation, you're probably doing it wrong, right? That means that you have broken the abstraction that you've tried to build through your inheritance, right? The whole reason that you have inheritance is so that you can collect common functionality up into a superclass. If you then just go ahead and break it by saying, okay, well, here's my superclass. Is it one of these things or is it one of these things? Is it a checking account or a savings account? You're probably doing it wrong, right? If you have to do that, then why did you make them all bank accounts to begin with? Right? So be careful of actually using this stuff. I just want to show you that they, in fact, are both true, right? That it is a rectangle, it is a square because of that inheritance. A square is a rectangle. A rectangle is a shape. But semantically, they're not because it's a 10 by 10 or 10 by 20. Right? So we've got a problem there. So to review, at least the pitfalls here, some languages allow multiple inheritance. For example, the cat-dog example. This results in the diamond problem. Which superclass does the class inherit from? In certain languages like C++, you can do this, but you have to have a mechanism to disambiguate where you are inheriting from. Java doesn't allow multiple inheritance for very good reason. This is kind of one of the things that was fixed in Java. Many other programming languages do not allow multiple inheritance for this reason as well. And because it's all a singly rooted inheritance hierarchy. The second problem is that you could design a hierarchy that's too deep. It's the yo-yo anti-pattern. In general, you should prefer to have a shallow hierarchy so that you're not sticking your head up and down like you're watching a yo-yo to determine what things you are actually working with. Better yet, prefer composition over inheritance, meaning that the composition that we did for bank accounts. A bank account has an owner. An owner is a person, right? I put them side by side. A bank account is composed of a person who is the owner of that account. I didn't put them into an inheritance hierarchy because a person is not an account, and an account is not a person, right? So you can take those out of the hierarchy entirely and use composition instead. And we'll look at another example later on. You also have, again, the rectangle problem. It may be, darn it, it's not formatting. Let me fix that. There we go. There we go. And if you have properties or member variables that semantically define an object, like a length and a width, and they have to be the same for a square, but you can mutate them, that is, set them, either in your constructor or some other way, such that it violates what it is. It's no longer a square because it's 10 by 20. Then you've got a very poorly designed inheritance. So you would need to refactor and change the higher and not take with that and not go with that design, because once you have made it, once you've designed a hierarchy, it's almost, and you start writing code that conforms to that hierarchy, it is almost impossible to break that hierarchy, right? You'd have to start from square one and redesign everything. So make sure that you have a well-defined and well-designed hierarchy that avoids all of these pitfalls and issues. Okay? All right. Let's see. Any questions so far? No? Then let's talk about the fourth pillar, which is going to be polymorphism. There we go. So the first type of polymorphism, in fact, when somebody says polymorphism, they usually mean subtype polymorphism. Right? In general, you can treat a subclass as a superclass, and in fact should do so if you don't need access to subclass methods. For example, when we went and designed our bank account, right? When I created a bank account, I said bank account A is equal to new savings account, right? And I won't bother with whatever details were in there. I'm creating a savings account. A savings account is a bank account, but the variable A here, it's referring to the bank account itself, right? It can do you can treat it like a bank account because it inherits everything that a bank account is. This would be this is I should say that this is good subtype polymorphism, or just polymorphism, right? This is bad, right? I'm not even using subtype polymorphism when I just create a savings account. B is equal to new savings account. Savings account. There we go. All right, when I do that, I'm not even I'm treating it directly as its subtype. That means that I wouldn't be able to put it into a general collection that has you've got 5 different bank account types, right? You can put all of those into one array list and then iterate over it and sum them all up, which is exactly what we did the last time we looked at this. But if you treat it as a savings account, as just a savings account rather than its super type, then you can't put that into an array list that has a bunch of different bank accounts. So if you've got 5 different bank account types here, that means that you have to maintain 5 different array lists in order to hold each one of the different types. Right? When you treat them like their super type, in fact, when you use subtype polymorphism, then you can put them all into one common collection so that you can simplify your code so you don't have to repeat yourself. So we don't have to write those 5 different methods, each one of them that does the same thing, but on a different type. Okay? This is good subtype polymorphism. And by the way, what does polymorphism mean? Polymorphism. Or what is a polymorph? So many changes, or many forms, right? Latin for many forms. What is a so we know the kingdom phylum thing, right? Do we know what phenotypes are? So within a species, way down here at the bottom with species, some species are they're the same species, but they're differentiated by their phenotypes. They're the same species, like a lion has different spots, right? Or a cheetah has different spots. That's their phenotype, right? So changes within the same population. That's what a phenotype is. Polymorphism in the context of code is treating treating those phenotypes. Is taking the idea of phenotypes that we can have many different variations, but then they're all the same species. We can have many different types of variables, but then we can treat them all the same. Right? That's what polymorphism basically means. As a consequence, in code, you can treat multiple types of variables or classes as one common type, right? Because they're all the same species. And another way of putting this is you can write one common solution that can be applied to many types of variables or classes. Right. What is the prime example of this? Even with C, where you don't have real polymorphism, you have this kind of generic idea. Remember what were the problems that we solved last semester with generic code? Comparisons, right? That I don't want to have to write a sorting function for integers, and then another sorting function for integers but in reverse order, and then another sorting function for doubles, and another one for doubles in reverse order, and another sorting function for students. A student object would have first name, last name. I could order them that way or in reverse. I could order them by their NUID. I could order them by their birth date. I could order them by whatever, right? And then all of those things reversed. How might we order a bank account? Let's see. Let's go over here to bank account. How might we order a bank account? It's got IDs, it's got a balance, and it's got an owner. Right? So if we wanted to sort we've got all of our accounts here. We've got 50 accounts. Not necessarily all the same owner. I'm talking about from the bank perspective now. You've got 50 accounts. You want to sort them. How are you going to sort them? How do you want to sort them? Just be straightforward. All right, so I could go to the owners and look at their last name, first name. Let's keep it simpler, though. Balance, right? Highest balance to lowest balance, right? How would I end up doing that in Java? I would end up, do I write my own sorting function? No, I go to collections.sort. But what does a collections.sort need in order to know how to order things? It needs a comparator. How do we build those comparators? Public static comparator. What is this a comparator for? C. I'll call it C, or CMP. Let me go ahead and import this. All right. What is this comparator comparing? I haven't built it yet. At this point, what is it comparing? Yeah, well, I have this big question mark, right? In fact, it is comparing something. It's comparing generic raw types, which is another term for objects, right? So I want this to apply to bank accounts, though. How can I make this apply to a bank account? By putting in this what's called a parameterization. And this is another form of polymorphism. It's parameterized polymorphism. All right, I've parameterized this type. All right, comparator before, that was a generic thing. What is it? What does it apply to? Well, it applies to objects. What if you want to apply it to a specific type? Well, it's a bank account, right? And let me go ahead and create this now. New comparator for bank accounts. Java 8, Java 8 or Java 7, you don't have to do the parameterization again, right? I do have to, oops, what's wrong? Okay, it's an anonymous class, so I do have to do it here apparently. Or that's just my, it's just my setup maybe, I'm not sure. Maybe I'm not using Java 8 or 7, whatever it is. All right, I'm going to compare those bank accounts. How do I compare those bank accounts? I simply go to their balances, right? So 01, I should call them A and B. I don't like 001 and 02. It's doing that because it was auto-generated, and it's treating them as object 1 and object 2. I'll go ahead and call them A and B. Return A dot, what is it, balance? Minus B dot balance, right? Now, we used that last semester. Should I be doing that? A balance is a double, which means that it can be a very large number, right? What happens with very large numbers and very small and very large negative numbers? Overflow, right? Or underflow. So the difference trick is something that should be avoided. What should I do instead? Don't be, in this case, don't be lazy. If A dot balance is less than B dot balance, so A has a lesser balance than B, right? A is less than B. Should it come first in my order? Do I want to go high to low or low to high? Which one do you want to do? High to low, okay. So if I've got A is less than B, then it comes after, right? And so if they're out of order, I should return a positive number. Else, if A dot balance is greater than B dot balance, then I will return a negative number. Right? And hopefully I'm second guessing myself. Right? Do we all agree with this? Okay. If not, then whatever. Right? This is a form of parameterized polymorphism because I've got a comparator that's parameterized. If I try to use this for any other type, let's say if I try to use this for strings, to compare a string to a string, it's not going to work because it's been parameterized to only work on bank accounts. But now here's the question. If I've got a savings account and a checking account, are those comparable? Yeah, in this sense, yes. Why? Because a savings account is a bank account and a checking account is a bank account. And so I can compare all bank accounts regardless of their type. Right? That's one of the advantages of writing generic parameterized polymorphic code. You don't have to write a comparator for, okay, well, what happens when, let's just take the savings account and checking accounts. If I'm comparing savings accounts to savings accounts, great, that's one comparator. If I'm comparing checking accounts to checking accounts, great, that works too. If I've got a checking account and a savings account, or a savings account and a checking account, right? Those are two more comparators. Or there are 4 or 5 cases in your comparator itself, right? And you don't want to do that. You want to use the common interface here that every bank account has a balance. And so you can compare any bank account to any other bank account. You've also seen this before, implicitly, elsewhere. Let's go ahead and go with a new class, demo. There we go. Oh, demo already exists. Cancel. Where is demo? There we go. All right, good. I'll go ahead and get rid of this. We've done this before. And get rid of this. All right. In fact, well, it had an example there. I'm going to create a list here of integers, right? IDs, right? New array list of integers. Right? Now, I can go ahead and add any integer I want. I can add 10, IDs.add 20. I can add IDs.30. Can I do this, though? Add 10. Well, it's already highlighting it in red, telling me that I can't do this. Why? It's not an integer, right? It's a string. And what did you say on line 11? You said that this is a list that holds integers. I can add an integer, I can add an integer, I can add an integer, and then at the end, I go ahead and try to add in a string. The compiler is smart enough to say, no, you parameterize this only for integers. It is a list only for integers. I'm going to, you told me that it was only for integers. I'm going to enforce that. And the way that it does it is with a compiler error here. Now let me change it. It's a list for what? It's an array list of what? Yeah, who knows now? The only thing that it can think of is, well, you've got a string, an integer. Well, what's the commonality here? You know, if I add a savings account and a checking account, well, that's a bank account. But then a bank account is what's way at the top? An object, right? It's treating well, this is now as a list of objects. It's kind of like doing it like this: list of object, right? And list of array list of object. You can throw whatever objects you want in there, right? You can have mixed types now. That's not a very good thing, because why would you have a collection of integers and strings when you pull them out and you try to add them? What is an integer plus 10 den? It's not defined. You're going to get a class cast exception of some sort. Yeah.
What does the turn the 10 into? Because I thought integers weren't objects. I thought they were primitive type.
Good point. Let me go back here to the integer. Right. So a phenomenon is happening here called boxing. Let me go ahead and create another example. Integer a is equal to 20, or 10, let's say, and int b is equal to 20. Right? Int c is equal to a plus b. And then I'll go ahead and add each one of those, a, b, and c. It's perfectly happy with all of this. Why? Here, I've got the wrapper class, which is an object. Here, I've got two primitive types, which are not objects. So consequently, over here with A, I've got functions I could call. I've got a byte value. I've got two strings, et cetera, et cetera, et cetera. Over here, down here with B dot, there's no such thing because it's not an object. It doesn't have methods. What's happening here is Java's changing my code so that it makes it compatible. And this is yet another example of polymorphism. In Java, they call it boxing and unboxing. So down here, when I add on this line here, when I add B, what it's doing is it's taking the primitive type and it's wrapping it up. It's in a box, right? It's boxing it. It's wrapping it up in a big I integer so that it's compatible with the collection and it can be added. Now, the reverse operation is called, well, what happens when you open a box? What do you call that? Unboxing, right? And so unboxing is occurring here on line 14, where I've got an object A plus a primitive type B. It says, okay, well, to make this compatible, I need to unbox this object to get its primitive type. Now I've got a primitive int. I can add them back together and give you a regular old int. This happens completely opaque to us. What's actually happening is usually the compiler is taking care of all of this for us. To make this compatible, A is an object. So what happens is it's actually going to replace my code with something that looks like this. Int val. What does int val return? You might not be able to see it here, but just a lowercase I int. Right? So the compiler is going in and say, this is an object, this is not an object. To make this compatible, I will add this method for you so that they are compatible, and that's what actually gets compiled to Java bytecode. It's called a boxing, auto boxing and auto unboxing, and you don't have to worry about it. Right? But it is a form of polymorphism because before I had mixed types. You can't add an object to a non-object, but those are built in, and Java knows how to take care of that for us. Right? It also gets dangerously close to something called operator overloading, which is something that we'll talk about here shortly. Right? But to go back to the, well, no, this is good enough. All right. Again, if you want to make everything an object. Right? You can promote everything up. And now you can add whatever you want. Right? IDs.add ten. Again, this is not an ideal situation because if you iterate over these and expect them all to be numbers, you have no expectations on them. The only expectation that you have on the things inside of this collection is what? Is that they are objects. And the only things that objects allow you to do are hash code, toString, right? Only the most basic of basic things are defined in the very topmost object class. And so you can't add them together safely. You can print them safely because everything has a toString method, but you really can't do anything with them other than this. Right? So this is why parameterized polymorphism is such a good thing, because I can go ahead and put a restriction on here that says that this particular array list or this list is only good for integers, and the compiler is now able to check my work here. Imagine if you didn't have this, if you lived in the Wild West, and you can put whatever you want in there. You can put whatever. Those are how dynamic typed programming languages work. PHP, JavaScript. You can have a Python. You can have an array of one of them is a string, one of them is an integer, one of them is a floating point number, one of them is an object. It's chaos, right? There's no way for you to enforce those kind of rules in a dynamically typed language. And up until Java 5, when they introduced generics and parameterized polymorphism, it was also the Wild West. You had to use what were called raw types. The raw types being object. Right? Oh. Right. Well, what can this be? It can be an integer. It can be a string. It can be whatever you want it to be. Right? It could be a new bank account or a savings account. There we go. And I don't have that constructor, but you can do this. Right? That's the Wild West. You don't want to do that. Right? It's chaos. Don't use raw types. Raw types are when you have an object. Okay? You have this gift of polymorphism. You should use that gift so that you can enforce sanity on your programs. Right? All right. Well, that's how. Let's look at another. That's how polymorphism works. What I want to do now is I want to show you how to write polymorphic code. Right? Using the built-in types, lists, array lists, sets, etc., like that. Those are perfectly fine. Right? You can use those pretty straightforward. But what if you wanted to write your own parameterized class? Right? You're not necessarily going to do this in your assignments. In fact, if you did this in your assignments, what are you doing? Because we didn't design the assignments that way. But as an example, where's my? There we go. This is what I want over here. Okay. What I want is a getMax method. So public static. Let's go with integers. Int getMax. Right? And I'm going to go ahead and have a list of integers. List, and let's go ahead and write this code. I want to find the maximum value in here. Right? So what I'm going to do is I'm just going to get the first one. Can I do that? Get 0. Int x. X is the first one, so I'll say that that's my max. Right? I'll assume that that's my max, and then I'll go through the rest of them for integer x in the collection list. If x is greater than the max, then I found something that is larger, right? So let me go ahead and update my max and return max. Right? Now come down here, and we've gotten rid of this now. This will be 10, 20, and 30. So let's go ahead and go with int max is equal to getMax of my IDs. Right? And that's it. And then system.out.println max. There we go. All right. It compiles. So hopefully it works. 30. Right, did it work? Great. All right. Well, I'm not always going to have a list of integers. Sometimes I will have a set of integers and a hash set of integers. Let me go ahead and import those. And what else is going to break here after I've re-imported these? What's breaking now? getMax, right? So getMax takes a list, right? and I've got a set. So should I go ahead and copy pasta, and change this to a set? Should I have two get maxes? Does that sound like a good idea? Bad idea. It sounds like a bad idea to me. What a set and a list. I want they're the same thing, right? I'm just iterating over them. I can iterate over a set. I can iterate over a list. What would the difference look like? The only difference would be that this would be a set instead, and I'd have to call them. And is that going to work? Yeah. Now that works. Oops. What's wrong? Compilation. Come on. Get max. Oh, I can't get the first now. Good. So there is a difference. It's no longer a list, too, either, is it? S. S dot, and here's how you get the first element in a set dot next, and then ignore it. Right? Ignore that. Right? What's the only the only difference is how I can get the first element, and the fact that I said that this is a list and this is a set. Does that seem like a good design? I've repeated myself quite a bit. So let's get rid of the second one here. How can I change this so that it applies to both lists and sets? What's a commonality? Let's use subtype polymorphism to promote these two ideas. Right? Do you remember that diagram from last time? What are they both? They're collections. So let's change this to a collection of integers and import that. There we go. So a collection of integers, a set is a collection, a list is a collection. Now down here, and again, I'm going to have to, I shouldn't call it a list, I should call it C, I guess. C dot iterator dot next, right? Old school Java. And then this is no longer a list, it's the collection C. And now it's happy, regardless of whether or not I use a list or a set. Right? And I've got one function to rule them all. Let's take this a little bit further. What if my IDs are now doubles? Right? Nothing down here changes because 10, 10.0, you can make that into a double. Right? Sorry, I would have to make a cast to double. Right? Yeah, there we go. All right. So let's go with 2.5, 3.5, and 4.5. Right? And then get the max, and this has to be a double. And then I can print it out. But it's still complaining. Why is it complaining? What is get max good for? It's good for a collection of integers. Okay. Should I go down the same path as I did before and change this to a double? And then, of course, this to a double. So I've got now two copies. Oh, and then the return type would be a double. Right. Good idea, bad idea. Let's make this a little bit more generic. I want this to work on integers, and I want it to work on doubles. So let me, do I have my web browser open here? All right, I'll bring it over here. Let's go ahead and look up what is a Java double and Java integer. There we go. What is an integer? An integer is a number. It's also an object. Sorry, go back. And what is a double? A double is an object that is a number that is a double, right? So do I have some common interface here? Number. Let me go back over here and change this to number. Okay? And this is going to be, and I can't call this an integer now because it could be a double, it could be an int. I don't know. What is that first element? It's simply just a number. Right? And I will be iterating over numbers, right, in the collection C. And then to make this comparison here, I need to say that C dot compare to not C, sorry, X dot compare to max. Right? And if that is greater than 0, then they're not comparable? What? No, it's comparable. Compare to. Okay, fine. We'll do it this way. If x dot double value is greater than max dot double value, then we'll go ahead and do it like this. In other words, it's going to automatically convert any integer over to a double, and we'll be fine. And then we'll return the max here, which has to be now a number. And this solves all my problems, right? This don't worry about this. This is a number. I'll go ahead and typecast this to a double. All right, I'll force it to become a double. Come on, what? Change. Fine. Number. There we go. Okay, it's still complaining, and I know why here. Okay, but don't worry. I can change these to numbers. Here's another solution. I can change this to a number. I can change this to a number, and well, 2.5 is a number, but also IDs.add. B was a number, right? So I can go ahead and add that, and now it's completely fine. B is 20, so it's probably going to return 20, right? Yep. 2.5, 3.5, 4.5, and 20, and it's giving me my max. Right? This still is not that satisfying, right? I had to change everything up here to a number. What if I did have a double array? Double, double. There we go. And now I can't add an integer, but I can certainly think about passing in just a double. Right? This is where named parameters come in handy. Right? I'm going to show you how this works. My return type is not going to be a number. It's going to be some type. I don't know what type that is. If you don't know what type it is, then what would you call it? Oh, kind of a variable, right? T. Right? And I'm going to parameterize it. I'll come back to that in a second here. And this will be of type T, right? What is the variable? What is type, right? So let's just go over here to the main and let me ask you a question. Int x is equal to 10, right? There are actually two things here. When I create an integer variable, it has a type and a value. What's its value? 10. What's its type? Int. Right? Well, x is a variable, right? That's the name of the variable. What if I want to vary its type as well? What if I don't know its type and I don't know its value? Right? I can do something like this. I can make its type variable. It could be an integer. It could be a double. It could be a string. Right? To do that, all you need to do is parameterize a function, parameterize a class, or parameterize a variable. You can parameterize anything that you want because everything is polymorphic. A variable can have different types. It can be a generic type T. A function can return various types, right? A function can take various types. And that's what I've done here. I've said that this is not a collection of numbers. It's not a collection of strings. It's not a collection of doubles. It's a collection of variable types. Okay? Now, that doesn't really much help me here because I can go ahead and vary the max here. But now the problem comes in when I've got type T, X in the collection here. How do I compare these two things? Right? How do I say that X is greater than the max? Right? What do I know about X? What do I know about max? Do I know that they're integers? No. Do I know that they're doubles? So I can't convert them to integers. I can't use that double value that I was using before. What's the only thing that I know about the variable type T right now? What do I know about every type in Java? That it's an object. And that's all I've got. I can go ahead and call anything that's in the object, right? I can say max.toString, right? I can convert it to a string and then maybe compare it. That would be kind of bad. I can get its hash code, and I can compare it according to its hash code. So I've made this too generic, right? Think of this as a progression. Down here, we had a getMax method that only worked for lists of integers. Then we had one that only worked for sets of integers. I promoted that up so that it works on any collection of integers. We promoted that up further so that it works on any collection of numbers, so that it'll work on both integers and strings. But I've gone too far. Now it will work, and I'm putting that in quotes here because it doesn't actually work. Now it'll work on any type, any object type. Right? And that's too generic because here's an object, how do you compare them? Right? I don't know. So what I want to do is I want to say that give it a minimal amount of interface. That my types, I don't know what they are, but they're guaranteed to say be numbers. Extends number. There we go. And what's wrong with you? Oh, sorry. Nope. It should be over here. There we go. Now I do have some information about the type T. I don't know that they're integers. I don't know that they're doubles, but I do know that they are numbers. And all numbers have that double value that I can now restore down here. X dot double value, if that's greater than max dot double value. All right, there we go. And now it works for any type. It could be doubles. It could be integers. All right, there we go. Of course, it's going to complain now that I'm adding this stuff. But now that I've changed those, it works as well, right? And I can also say that now that this is an integer, right? Because my array list was an integer, and getMax, and it's 4. GetMax returns what? It returns. Does it return an integer or does it return a double? It returns a type T. It takes a collection of type T, meaning that if you pass in a list of a collection of integers, it's guaranteed to return an integer because that type, these two types match. T and T, those are the same things. If you give it a collection of doubles, then it'll be guaranteed to return a double, right? So that's I made it too generic. I brought it down a little bit in the hierarchy so that I actually have a minimal amount of interface here to work with, double value. But now let's take this a little bit further. Right? Numbers are not the only thing that are orderable, right? I can sort integers, but what else can I sort? Strings or bank accounts. Right? So let's make this a string, and let's make this a string. Right? And now I can't add these anymore, but I can add 2, 3, and 4. Right? GetMax is now complaining, though, because when I call this on an array list of strings, that means that T gets magically replaced with string, meaning that, that the collection is of type strings, and T, it's going to return you a string. But what are we violating here? Is a string a number? Nope. In fact, we can look it up here. A Java string. A string is an object. It's not in that part of the hierarchy. So double is a number. An integer is a number, but a string is not a number. It seems like I should still only have one getMax function, right? Do I need a getMax function for all? Now I've taken care of it for all collections of numbers, but now I want to take care of it for strings. Maybe in the future I want to take care of it for bank accounts, right? Which is basically just essentially a number again if I want to do it by balances. I still don't want to have to write a getMax function for the rest of my life. So one thing I can do is instead of extending number, I can extend an interface. Right? T is going to be any type that is comparable. A string is comparable. You can compare one string to another string in lexicographic order. An integer is comparable to an integer. A double is comparable to a double. Right? And when I do that, I can no longer use this interface. Now what do I know about X? And what do I know about max? Right? X dot, there is a minimal amount of interface here. Comparable means that it's got this function compare to that returns an integer, positive, negative, or 0, depending on the relative ordering of these things. And I'll compare it to the max. And if that is greater than 0, then I will update my max here. Right? And now this string is going to be max. There we go. And we'll output max. So 2, 3, and 4, which one's the largest one? Lexicographically now, alphabetically. 2. So did I do it right? Yeah, I did it right. I've got now one getMax function that will work for anything that is comparable. Numbers are comparable, strings are comparable. But are bank accounts? Bank account and bank account. Let me go over to my bank accounts. Where are they? Bank account. So it implements account, but does it implement the comparable interface? Nope. So I could come back and make a change here. It implements comparable, there we go, of bank accounts, right? And when I do that, Did I already do this? Huh. That's weird. Oh, because it's an abstract class. So now my subclasses are probably complaining about it, that it's not comparable. So let me go ahead and take care of that. I will add a public int to compare to, right? Bank account that, right? What I'm going to do is I'm going to compare this and that, right? I'm just simply going to compare them by their balances. So I could say if this dot balance is greater than that dot balance, then I will return something negative, right? Because we want larger balances first. So if this balance is larger, then that comes first. Otherwise, else if this dot balance is less than that dot balance, right? Then I'll return something positive, and else return 0. I've made it comparable. Now my subclasses are happy, by the way, because it's inheriting that compare to method. And over here in the demo, the compiler is now happy as long as I make this a bank account. A bank account with the maximum balance is going to be returned from this. And it's perfectly happy here now. Obviously, it's not happy here because I'm trying to add strings that are not bank accounts. And unfortunately, I deleted all my other code, but you can see that it'll work. Hopefully, I don't have to prove it to you, right? But I deleted all the code that had my my bank accounts all over the place. Okay. So I have now made this as generic as possible. As long as you make your class comparable, then you can use this getMax function. In fact, it sounds so useful. It probably already exists. In fact, it does. Collections.getMax, right? There are two variations. One of them is like this, that just takes a generic collection and returns the maximum value because they're comparable. There's a second version that takes a collection and a comparator so that you can override that. Right? You say that you sorted your you don't want the bank account with the maximum value. You want the bank account with the minimum value. There is no getMin function. There is no collections.getMin. Why? Because you can just write a comparator that reverses everything and then use that. There's only one getMax function. Right? You can change it into a getMin function by writing another comparator that reverses the order. Right? This is parameterized polymorphism. You have to have a certain minimum amount. You can make it as generic as you want. I started way down here, made it more generic, more generic, more generic, until I went too far, right? And then I brought it down a little bit, brought it down, then I went up a little bit with the compare to method. Let me go ahead and review this with a couple of examples. And I don't want to have to type too much, especially since we're low on time here. And again, you're not going to use hardcore polymorphism. Use it in that on your projects in that you should be using the collections library. You should be using lists. You should be using sets. You should be using maps. Those will make your lives way easier if you start using those collections. You'll be using the parameterizations. Right? That's how you'll use polymorphism. And of course, subtype polymorphism. So let's take a look at these various pieces of code here. What do you know about stuff? The question mark here is a new piece of syntax. It's even more generic than T. It doesn't even have a name, right? It's called a wildcard. Anything, right? Again, Wild West. The question mark is whatever you want, right? If we use the question mark, however, alone, all we know about stuff, that list of stuff, what is that stuff? All we know is that it's an object. And I can't do anything with it, right? I can get the first element and treat it as an object. I could say print it. I could take its hash code, whatever else I can do with an object, but there's not much else I can do with it. But if we name the parameter, then I can start to play with it a little bit more. Right? I've parameterized this with T now, and so T has a name. It's no longer just question mark, I don't know. Right? We're calling it T. If you give me a list of elements where T is now a string, now I can treat item as a string, right? I'm not treating it. I can't treat it inside the function as a string, but I can actually name it, right? Instead of having to before it was object, right? Now I can actually name it, right? T. Still not too useful, so we can provide some additional bounds. If I say that T extends bank account, and I've got a list of accounts, then I can start to work with it. One thing that's common to all bank accounts is that get balance method. I can sum them all up, right? And that's what I've done here. I've just had a total. They could be checking accounts, they could be savings accounts, they could be whatever kinds of accounts you want. By putting that extends there, I'm basically bounding that parameterization and saying that I don't know what T is, but I do know that it's a bank account. And all bank accounts have this get balance method. But we didn't actually use the variable type T, did we? Look at the function body, lines 3 through 8. Did you see T there at all? Capital T by itself, not, of course, total has a T, a couple of T's, right? I'm talking about capital T. Nope. So we don't actually need it. What I can do is I can put a question mark there. And that makes it a little bit more generic. I still know that they're all bank accounts, but I could have a collection purely of savings accounts. I could have a collection purely of checking accounts. I could have a collection of bank accounts with a mixture of the two. And this will work with all three of those choices, right? Because I put in a question mark now. I don't care what it is because I'm not going to use it. Right? However, if you do need to reference something, then like make a reference to it. Like for example, this is just called buzz. What we're doing is we're creating or we're given a list of accounts and then a particular account, and we check, does it have a positive balance? If it has a positive balance, then we go ahead and add it to that list of accounts. Again, this is a toy example. This is not necessarily code that you should write, right? But by putting that T back in there, we've now enforced a type. The list is a list of type T. The single account is an account of type T. Now we're saying those two things have to match. If you have like a collection of savings accounts, then this single account over here has to be a savings account. You can't mix savings accounts and checking accounts. Or you can use both, right? You can get really, really complex here if you really want to. We do know that T is a bank account, but the list, it's a list of whatever as long as it's a superclass of the type T, right? So we're actually lower bounding it here now, right? Lower bounds, I get mixed up with upper bounds, lower bounds, right? We can go, oh, I guess that's all the further that I went, looks like. Yep. Yeah, that's all the further that I went. This arguably is a little bit too generic, but I've seen stuff that has very, very complex generic stuff. So if you're interested more about this, it's called PEX. The tutorial that I just went through was we started down here way too specific. Then we worked our way up. We went too far, and then we had to come back down, and then we wanted to go back up until we found that happy medium of the design that we were looking for. That kind of design process is guided by something called PEX, which is a producer extends consumer super principle, right? And if you want to read all about that because you want to make your code super, super generic, go ahead and be my guest. You won't necessarily have to make anything in this course that complex. Right? But if you are designing, say, the collections library in Java that everybody is going to use, then you definitely want to make sure that you get that right balance of it should be right here. No more generic than it needs to be, no more specific than it needs to be. It's in what we call the Goldilocks zone. Why do we call it the Goldilocks zone? It's not too cold, it's not too hot, it's just right. That's what Earth, we get that also from astronomy. Earth is in the Goldilocks zone. Mars is just on the very end of the Goldilocks zone, so it's not a habitable planet for us. And it's not too close like Mercury or Venus because then we would get fried. So we're in the Goldilocks zone, not too hot, not too cold. And that's the idea behind this kind of polymorphic design. Right? You want to make it generic so that you don't have to rewrite solution after solution after solution, but you may need to make it a little bit specific so that you can actually write a solution instead of just say, well, this is an object, go ahead and output it to the standard output or something. Right? All right, we'll continue there on Tuesday.